Hello everyone, myself Hans. Today we are going to solve the given problem from topic dynamics and the chapter is central orbits. Question is given, find the law of the force to the pole when a particle describes the curve AU is equal to tan hyperbolic theta by root 2. Let's solve the problem. Given curve is AU is equal to tan hyperbolic theta by root 2, and we know that the differential equation of central orbit is differential equation of central orbit is d2u upon d theta square plus of u is equal to p upon h square into u square. Here p is the central force. So let this equation 1 and let this equation 2. Differentiating equation 1 with respect to theta, we get A is the constant here, so we have to u differentiating with respect to theta, we get du upon d theta. And tan hyperbolic, let's suppose theta by root 2 is theta, so differentiating tan hyperbolic theta by root 2, we get here sec square sec hyperbolic square theta by root 2, and again theta by root 2 differentiating with respect to theta, we get here 1 upon root 2. And from here we can also write here once again. From here we have to write here, this is du upon d theta is equal to 1 upon of root 2 into a. A is taken to denominator of 1 upon root 2, and here is sec hyperbolic square theta by root 2. And from here we know that a du upon d theta is equal to, here sec hyperbolic square theta is written as 1 minus of tan hyperbolic square theta by 2. Sec hyperbolic square theta by 2 is written as 1 minus of tan hyperbolic square theta by root 2, and here is 1 upon root 2 is already present. And in the given question from equation 1, the value of tan hyperbolic theta by root 2 is AU, so we have to put here, this is du upon d theta, and a is taken to denominator, this is 1 upon root 2 into a, and here 1 minus of, in place of tan hyperbolic theta by 2, here tan hyperbolic square theta by 2. Here the value of tan hyperbolic theta by 2 is AU, so we have to put here a square into u square. And further from here we can also differentiating again with respect to theta, we get here d2u upon d theta square is equal to 1 upon of root 2a is constant, and here 1 differentiating with respect to theta, we get 0, and a square is also constant. U square differentiating with respect to theta, we get here 2u, and again u differentiating with respect to theta, we get here du upon d theta. Further from here we have to put the value of du upon d theta here. We can put here that this is d2u upon d theta square is equal to, multiplying with this, we get here 1 upon of root 2a into minus of a square into 2u, and we have to put the value of du upon d theta. From here we get 1 upon of root 2 into a, and here is 1 minus of a square into u square. And further we have to multiply here, once again a to a is cancelled out, A to A is cancel out, and root 2 into root 2 here. Once again, A square. So we have to multiply A into A. This is A square. A square is cancel out, and here is 2. Root 2 into root 2 we get 2, and 2 this is also cancel out. Then remaining is here minus of u. We have to writing here d2u upon d theta square is equal to, here is minus of u, multiply with this we get here minus of u plus of a square into u cube. And from here you have to, using the equation 2, the differential equation of central orbit, using equation 2, the differential equation of central orbit, we have to put in the value of d2u upon d theta square here, and we can also write here the given equation in the writing form. We have to writing d2u upon d theta square, minus of u is taken to left hand side, we get here plus of u is equal to a square into u cube. The value of here d2u upon d theta square plus of u is equal to a square into u cube. Using the differential equation of central orbit, equation 2, we have to put in place of d2u upon d theta square plus of u, we have to put in here, this is a square into u cube is equal to, here is p upon h square into u square. And we have to show that the law of force. So we have to writing here once again, we have to writing here once again p, wait, we have to writing p is equal to a square into h square into u to the power of 5. And here at an f you have to writing here u is equal to 1 upon r. We know that in the central orbit u is equal to 1 by r. So we have to put in place of u, we have to 1 by r. We get here p is equal to a square into h square upon r to the power 5. And we have to write here, this is central force is directly proportional to 1 upon r to the power of 5. This is the required solution of the given problem. Thank you class, and thank you for watching.